So here's the Schrodinger equation. I'm going to deal with the free particle. That is the situation where the potential is 0. That means the energy is just kinetic energy, 1/2 mass times velocity squared, or sometimes written as momentum squared over 2m. If I plug that in here, I get that the second derivative of psi with respect to x is equal to 8 pi squared m over Planck's constant squared times p squared over 2m. Notice m's cancel, 1, 2 cancels. I'm sorry, this shouldn't have been an equals, this should have been a plus. And it's all equal to 0. But notice now, this 4 pi squared over Planck's constant squared, well, that's just 2 pi over Planck's constant squared. And this p squared, that's just momentum. So this becomes the second derivative of psi with respect to x squared plus 2 pi p over Planck's constant squared times the wave function. But wait a second. Momentum over Planck's constant is 1 over the wavelength. So what I end up with is 2 pi over the wavelength. But 2 pi over the wavelength is simply the wave number, k. So the equation for a free particle is that the second derivative plus k squared times the original function equals 0. So what are the solutions to this equation? That's not too difficult. Certainly, either a cosine or a sine would solve the equation, but it's simpler for us to say that psi is a e to the plus or minus I kx. Instead of using either sine or cosine, we use plus and minus I kx. Plugging that in here, the second derivative of psi with respect to x squared is plus or minus I squared k squared a e to the plus or minus I kx. Now, whether it's plus or minus, when it squares, that goes away. But the I squared is going to be negative. So this is just negative k squared times the original psi, a e to the plus or minus I kx. Which means it solves this equation. I get negative k squared psi plus k squared psi equals 0. But if I add this to my time dependence, I get psi with the time dependence, make it a capital psi, is a e. If it's a plus, then it's e to the I kx minus omega t, which is a wave moving to the right. And if I use the minus, then it's a e to the negative I kx plus omega t, which is a wave function for a wave moving to the left. So I find that my solutions to the free particle Schrodinger equation are just waves of wave number k, momentum p, turns out to be h bar times k, and they can either be moving to the right or moving to the left.